All right. Good morning, everybody. Today we're going to start talking about constant of proportionality. Okay, and it's new terminology, but it's something that we've actually been doing, or that we've already did. Okay, so let's go over our notes. Okay, so two quantities are proportional, and we've talked about this. They're proportional if the ratio between the quantities is equal. Okay? We've also used the word constant. Okay? And the same. Okay? All right. So 1 through 3 here, we're going to use the box, and we're going to see what they are talking about. Okay, so Mario travels 180 miles in 2.5 hours. If Mario travels at the same rate, how far can Mario travel in 5 hours? Okay, so we have a rate. Okay, and it's talking about traveling the same rate, and then it asks how much or how far you can go in 5 hours. So first thing we need to do, we need to take our rate, all right, and if we go back and look at our notes, we're talking about in terms of x and y, okay, and I told you that we always do y over x, okay, and with that, our x, if we're talking about time, will be on the bottom. Okay? And if we talk about money, it will be on top. So in this one, we're talking about time. All right? And that's hours. So I'm going to go to number 2, and I'm going to do like we did the other day, and I'm going to label my table. So hours, that measures time. So that's my x, y is my miles. So we write it y over x. So 180 miles over 2.5 hours. Okay? Now, to do this, we need to find the unit rate. All right? So the first thing we need to do, we just need to divide. All right? So 180 divided by 2.5 will give us 72, and that's miles per hour. Miles per hour, or mph. Okay? Now, once we have our unit rate, all right, well, it says that he traveled the same rate. All right, so if he's traveled the same rate, he traveled 72 miles an hour. How far can Mario travel in 5 hours? Well, all we need to do is take 72 miles, okay, per hour, and multiply it by 5 hours. And that's over 1, okay? So what happens is our hours will cancel out, and then we get 72 times 5, which would be 360 over 1. Any number over 1 is just the same number. So 360, and we're left with miles. Okay? So he can travel 360 miles in 5 hours. All right, let's go to number 2. Number 2, using the information about Mario's rate, complete the table below. Well, how many miles did he go in 2.5 hours? Well, he went 180. Okay? Now, in 5 hours, we just figured this out. 5 hours, how far did he go? 360. Okay? Now, we can take his unit rate, this is how fast he was going, 72 miles an hour, and we can multiply it by our hours to find out how far he went in that amount of time. Okay? 7.5 hours, well, at 72 miles per hour, we just multiply those two together. All right?
Faculty, you need to take your pictures today.
So we get 540. Okay? 540. All right? So we take 10 times 72. Well, that's 720. Okay? 12.5 times 72 gives us 900. All right? Now, so anytime we find the unit rate, we can just multiply by the hour, and that'll give us the miles that he went. Number 3, how many miles does Mario travel in 1 hour? Well, from number 1, we had to find that. We had to find the unit rate. Okay? And he goes 72 miles in 1 hour. So he goes 72 miles. All right, now it says explain your solution. Okay, well, you must find the rate, the unit rate, to give you the amount traveled. Okay. In 1 hour. Because if we remember, the unit rate has a denominator of 1. Okay? Has a denominator of 1. Alright, so this is kind of like a little refresh of what we did. Alright, talking about unit rates and using a rate to find out how far they'll go in a given time. Now to get into constant proportionality. So the constant of proportionality is the value of the ratio of two proportional quantities. Okay? And that's just meaning that they are the same. They are equal. Okay? That each relationship, the unit ratio, is the same between those hours and miles in this case. Okay? All right? And the constant proportionality is represented by the equation. And this is the one that we're going to use right now. Y is equal to kx. Okay? Where y represents the y values. So in our case, the y values are the miles. So the y's would go where the w is. Okay? And the x represents the x values. Okay? So the x values is our hours. Now, another one that we can use is k is equal to y over x. Okay? Now if you notice here, k is equal to y over x, well, y over x. Okay, right here. Alright? So the constant proportionality is basically our unit rate. So the y divided by the x. Okay? Now, let's look at number 4 here and let's figure out the y over x. Alright? So let's figure out the constant of proportionality, the y over x. Okay? So my y's over my x. So this one would be 12 over 1. Okay? Now 12 over 1 is just 12. Okay, you just 12 divided by 1. This one is 24 over 2. The next one, 36 over 3, 48 over 4, and 60 over 5. Okay. Well, about lost my camera there. Alright, so this is a 5. Alright, so we're just going to divide. Alright, so 24 divided by 2. Well, that's 12. 36 divided by 3. Again, that's 12. 48 divided by 4. Again, that is 12. 60 divided by 5. That is also 12. So all of these, they equal to what? 12. Okay. Now, let's look at the questions here. How do you know that the number of feet is proportional to the number of inches? Well, what have we said before about identifying proportional relationships? That they all must simplify to the same number or ratio, right? So, they simplified to the same y over x value. Okay? They simplified to the same y over x value. And I'm just going to put same number. Okay. All right. Now, that's how we know they're proportional. Okay. Now, this tells you, all right, y over x, the constant of proportionality is equal to y over x. So in this case, the constant of proportionality is 12. Okay? The unit rate is 12. They change the same each time. B, using x, the number of feet, how do you find y, the number of inches? Well, we can go up here and use this equation. So, all right, this is our constant proportionality, one of our equations that we're going to use. Okay, using x, so we're going to know x. How do you find y? Well, how do we find this? Well, when two numbers are next to each other like this, that means we multiply them. Okay, so we can multiply x, okay, well, I'll say we can multiply value of x, because we can put any number we want to in there for x. Okay, the value of x by 12. Okay, because 12 is my k. Alright, so we can multiply the value of x by 12, and that's going to give us y. So 12 times 1 is 12. 12 times 2 is 24. 12 times 3, 36. 12 times 4, 48. 12 times 5 is 60. Okay, now we're going to flip over to the next page. Okay. Now, at the top you can see it says y equals, k equals, and x equals. Well, we're just going to go back and look at the front page, okay, and write down what y equals, well, or what it is. So y represents the y value, or the y values. Okay? K, well, that's that new word we talked about, and that's constant might run out of room of proportionality. Okay? And X, well, it represents X values. Okay? Now, K is our unit rate. All right? Basically, K is telling us that the relationship goes up by a certain amount each time. Okay? It goes up a certain amount each time, like a unit rate would. All right, so it says, apply your understanding of the constant proportionality to the questions below. Okay? So number 5. While training for a marathon, Keith's watch reported how many calories he burned at each mile marker. The data is shown below. All right, so we have miles and we have calories burned. Okay, so miles 1 through 5, and then there's his calories. Now, what we need to make sure we do is label our table X and Y, or Y and X. Okay, and if you remember, I also showed you we do Y over X. Okay, and the Y is the effect, X is the cause. So X causes the other to change, okay, which that affects it. So if we look at this, which one do we think affects the other? Do the miles we run affect the calories that we burn? Or does the calories we burn affect the miles? Well, if I burn 117 calories, does that necessarily mean I ran a mile? No. I could have been doing something else and burned 117 calories. But I ran 1 mile and I burned 117 calories. So my X is my miles. My Y is my calories burned. Okay, now we need to understand that. Okay, so we understand how to set these up correctly. So A, is the number of calories proportional to the number of miles? Explain your thinking. Well, just like we did last week, all right, we're going to do Y over X, and we'll simplify them, okay? So 117 over 1, 234 over 2, 351 over 3, 468 over 4, 585 over 5. Okay, now I had to write them small. I didn't have much room. Okay, so then we just divide, right? So, and I'll write these above here. So 117 divided by 1, well, that's 117. 234 divided by 2, 117. Okay, you're going to find out that all of these simplify to 117. Okay, so is it proportional? Well, yes. Okay. And that is because for every mile he runs, well, how many calories does he burn? He burns 117 calories. Okay? And that basically tells us that they all simplify to 117. Okay, so on to B. The next day, Keith ran 7.5 miles. How many calories did he burn? Well, we know that he burns 117 calories every mile, right? Okay. So let's look at this equation. Okay. Now, the miles represent which variable? Well, the x variable. Okay. So I'm gonna go out here and write it so I can have more room. Okay. And k is my unit rate. All right. So if they all simplify to 117, well, that's what y over x equals. Okay. So I can do y is equal to 117, and I'm going to put this in parentheses, 7.5. All right, I just multiply those two together. Okay. When I multiply those two together, y is equal to 877.5 calories. So how many calories did he burn? Well, if Keith ran 7.5 miles, he burns 877.5 calories. Okay? Now, C, what is the constant of proportionality? Well, if we remember, K is equal to Y over X. Well, what did we find out Y over X was? Well, we divided them all, and it turned out to be 117. So, K is equal to 117. All right. K is your constant proportionality. Okay. Now it says write an equation to explain the relationship between the number of miles, here's your x,